Today, I'm going to show you how to set up a feature-complete Java development environment using Neovim. As a full-stack developer and Neovim enthusiast, I've fine-tuned my Neovim configuration specifically for Java, and I'm sharing the starter kit with you today. More specifically, I'll cover how to set up syntax highlighting, a Java LSP, auto-completion, snippets, formatting and linting, code actions, debugging, and unit testing. But before we get started, I'll be building on top of my previous Neovim configuration, so if you missed my Neovim starter kit video, I highly recommend watching that first. I've also made this new Neovim starter kit for Java available on my GitHub, which has almost everything configured for you already. You can find the link in the show notes. First, let's start with an easy one: syntax highlighting. If you are using my Neovim starter kit, then this should already be working. This configuration uses TreeSitter with the auto-install option set to true. This means that TreeSitter will automatically install syntax highlights when a new file type, such as Java, is encountered. Next, let's use Neovim's LSP support to connect to a Java language server. LSP stands for Language Server Protocol, which allows Neovim to connect to a language server to provide many of the features that modern IDEs have. There is really only one Java LSP worth mentioning, which is JDTLS. It's a bit finicky to configure correctly and can be a bit fragile at times, but it provides nearly all of the functionality you are used to in IntelliJ or Eclipse. To integrate JDTLS, there are a number of configuration files that we need to add or update. First, let's add the LSP server itself by updating our Nvim LSP plugin spec. Find the Mason LSP section and add a new entry to the Ensure Installed property called JDTLS. This will make sure that when Neovim starts, the JDTLS language server will be automatically installed. We also have to add a condition to tell our Mason LSP configuration not to load JDTLS when it initializes the other LSP handlers, because JDTLS has its own way to attach to sessions, which we'll see shortly. Without this condition, you will end up with two JDTLS processes attached to your session. While we're here, we'll also introduce a new plugin called Mason Tool Installer. Similar to Mason, which allows automatic installation of language servers, Mason Tool Installer allows automatic installation of supporting tools, in this case, Java Debug Adapter and Java Test. We'll cover these tools in more detail in a few minutes. We will also install a new plugin called Nvim JDTLS. The JDTLS configuration is complicated, and this plugin will make the setup much easier. Create a new file in the plugins directory called nvimjdtls.lua and add the lazy plugin spec after the return statement. The FT property tells lazy to only load the plugin when opening a buffer with the Java file type. Most plugins would get configured directly in their plugin spec file, but Nvim JDTLS is different. We need to create a file called java.lua in the FT plugin directory. The file must be called java.lua because it will be loaded automatically whenever a matching file type is opened in a buffer. If you are feeling sadistic and want to configure this from scratch, you can copy the contents of this file from the Nvim JDTLS GitHub page in the show notes and follow the instructions on that page. Instead, I highly recommend using the Neovim starter kit for Java that I've provided. This will save you a lot of unnecessary hassle. If you take this route, you will only have to update a couple of spots marked with to-dos. For the first to-do, simply update this to point to your JDK installation. You need to have Java 17 or higher installed. The second to-do is similar, so update this to point to any Java runtimes that you wish to use for your projects. After restarting Neovim, JDTLS should now provide basic LSP functionality, such as displaying hover information, jumping to a method definition, and auto-completion, which we'll go into more detail next. If this isn't working for you, run the JDT showlogs command and investigate any errors that you encounter. In my experience, this is sometimes the hardest part. Take your time and work through the errors. Auto-completion is one of the most valuable features of modern IDEs. As you type, you can see a menu of helpful completion suggestions. Since we just configured our LSP, you should now see language-specific suggestions in the completion menu, such as modules, classes, methods, functions, and variables. As you cycle through the suggestions by pressing Tab, the related documentation will also be displayed. In addition to LSP-based auto-completion, you can also see a different type of suggestion in the completion menu called Snippets. Snippets are templates for common coding patterns that will save you from having to write a lot of boilerplate code. After choosing a snippet, you can fill in template parameters and cycle to the next parameter with the Tab key. You can even create your own snippets, but I'll cover this in a separate video. Another common IDE feature is automatic formatting. JDTLS provides support for formatting code out of the box, which I have mapped to LeaderGF. You can use this key binding for highlighted code in visual mode or an entire file in normal mode. Nearly all IDEs come with some way to validate syntax and enforce language style guides. This is called linting. With JDTLS, this should be working without any additional configuration. As you can see, syntax errors and warnings will now be shown in color-coded virtual text. You can jump to the next diagnostic message with LeaderGN and previous message with LeaderGP. JDTLS also comes with something called code actions, which you may be familiar with if you've ever used Eclipse or IntelliJ. To execute a code action, navigate to the line or variable that you want to act upon and press LeaderGA. This will bring up the Code Actions menu, where you can choose from a number of common LSP-based refactoring options. You can also use LeaderRR to rename the current variable, method, or class across the entire project. There's nothing wrong with occasionally print logging your way through a bug troubleshooting session, but a proper debugger can save you hours of time. To add Java debugging functionality to Neovim, we'll utilize the Java Debug Adapter tool that we installed earlier. We'll add a few sections to our ft plugin java.lua file to integrate Java Debug Adapter with JDTLS. First, we'll add a variable that points to the location of the Java Debug Adapter that Mason installed earlier. Then we'll reference the bundles from within the LSP configuration. Next, we'll tell the LSP to automatically create debug configurations by searching our project for main methods, as well as enable the ability to hot swap code during debugging. We can also optionally add additional debug configurations to our nvim-ui.lua file. We'll add a custom launch configuration which sets the max heap to 2 GB, but you can use this to configure any custom options you want. We'll also add 2 configurations for attaching to commonly used debugging ports. Lastly, we'll add another configuration that you can customize for a specific project if needed. These will show up as options when we start a debug session. After restarting Neovim, you can now add breakpoints to your code by pressing LeaderBB. Once a breakpoint is set, you can press LeaderDC for Debug Continue, which will start a debug session. You should see the DAP UI tools appear. When stopped at a breakpoint, you can press LeaderDI when the cursor is on a variable to see the debug information for that variable. You can also jump around to different debug panels, just as you would with any other Neovim windows. The Scopes panel will show the list of current variables in scope. You can expand and collapse variables by pressing Enter. The Stacks panel will show you the current stack. The Watches panel can be edited just like a standard buffer to add expressions to watch. The Breakpoints panel shows all of your current breakpoints. The REPL panel allows you to write temporary code that is executed immediately at the current breakpoint, just as if it existed in the actual code at that line. If this feature doesn't motivate you to stop print debugging your way through life, nothing will. Lastly, the Console panel will show you the current program's console output. You can step over with LeaderDJ, step in with LeaderDK, step out with LeaderDO, and continue with LeaderDC. The Starter Kit also uses a DAP virtual text plugin, so you can see the values of variables inline as you step. You can also terminate the session with LeaderDT. You can find these and many other key mappings in the key maps file. Take some time to learn the key mappings or customize them to suit your needs. The last, and one of the most important topics I wanted to cover, is unit testing. We can now integrate the tool we installed earlier, Java Test, by again updating our ft plugin java.lua file. Let's also add a key map for running an entire test class with leader_tc, as well as a key map for running a single test method with leader_tm. Now, if we put the cursor in our unit test class and press leader_tc, it will execute all of the unit tests in the class as well as start the DApp UI. You can see the results of the test in the REPL panel. You can also run a single unit test by putting the cursor inside of that test method and pressing leader_tm. If one of our tests are failing, we can also put a breakpoint in the test by pressing leader_bb and then executing the unit test. Just like in our previous debugging example, the DApp UI will pause at the breakpoint, and you can debug just as you would any other code. At this point, you should have a feature-complete Java development environment that stacks up against IntelliJ and Eclipse. If you have any comments or suggestions for additional plugins or Java-specific configurations, I'd be happy to review a pull request. For additional Neovim resources, you can check out my Neovim playlist on YouTube, here or in the show notes. Make sure to subscribe to see more great Neovim videos like this in the future.